This is video 3 on antacids for the drugs and medicines unit, and you guys are probably familiar with the picture you can see there in the upper right hand corner. Those are Alka-Seltzer tablets, and you might remember that we used those a few months ago when we studied rates of reactions. But an Alka-Seltzer tablet is an example of an antacid. So what is an antacid? Well, when you have the process of digestion going on in your body, you are using HCl that's produced in your stomach and to break down your food. And sometimes your stomach will produce too much hydrochloric acid. Now, the hydrochloric acid in your stomach is not concentrated with a very high concentration. It's usually, I'm sure it varies from one individual to another, but it's about 0.1, 0.12 molar. So it's not too concentrated. But sometimes your body will produce too much of that, and that can cause either an upset stomach, or sometimes it rises into your esophagus and causes heartburn. And you might even have seen some commercials where that condition becomes pretty severe, and it's called acid reflux. Now, antacids are taken by mouth, and they work by neutralizing that excess acid in your stomach. Now, they can vary with what kind of ingredients they contain. So some of them will contain aluminum hydroxide, some will contain calcium carbonate, and that's usually what you think of when you think of like calcium carbonate is like a Rolaids usually. Magnesium hydroxide is usually something like milk of magnesia, and then sodium bicarbonate is what we saw in Alka-Seltzer. And it can be that there's a combination of these ingredients as well. Now, what an antacid also might contain is something called an alginate or an anti-foaming, or excuse me, alginate and an anti-foaming agent. They're two different things. And the purpose of those being in the antacids, an alginate is there in order to form a protective layer over the walls of your stomach and your gullet, like your esophagus, your whole digestive tract. So they basically form a protective coating so that that acid doesn't eat away at the tissue in your digestive tract. The anti-foaming agents are added to reduce the amount of CO2 that you get in your GI tract. So here's an example that I can give you, and I don't know how many of you have ever taken a Tums, but a Tums is basically like chalk, calcium carbonate. And when you take a Tums, calcium carbonate, I hope you guys know enough chemistry that you realize that when you react a carbonate with an acid like HCl, one of the products you're going to get is a CO2. And when there's only two ways CO2 is going to leave your body. And it's either out the end it came in or out the opposite end. And so what it's trying to do is reduce the amount of bubbles that would be produced in your stomach so that you are either not burping or passing gas. Okay? I bet you never thought you'd hear that in a video. Antacids differ in how quickly they work and how long they provide relief. So if you can dissolve rapidly in your stomach, you're going to get relief much more quickly. So things like magnesium hydroxide and sodium bicarbonate, they dissolve really, really quickly. Things that contain aluminum or calcium carbonate are going to take a little longer to work. Now, the longer that they can stay in your stomach, the better they're going to be. They're going to work for a longer amount of time. And these things are sold with brand names like Alka-Seltzer, Maalox, Mylanta, Tums, Rolaids, and then you can also get them in generic forms. All of the things that I've just mentioned are over the counter, and they come in various forms. So you can either get a tablet, you can get, sometimes like with Alka-Seltzer, you dissolve the tablet in water and then drink it. Sometimes they're liquids themselves, etc. There are also remedies that are prescription antacids that if you suffered from a more severe condition of acid reflux that your doctor would prescribe for you. Okay. So one of the things that IB will ask on paper 3 when you're doing your drugs and medicines option, almost every year I've seen this, they want you to be able to write a reaction of some ingredient contained in an antacid with the stomach acid produced. And they don't often tell you the formulas for these things. That's why we make you memorize those polyatomic ions. So I've got a few that I'm going to have you try. So like if I ask you to write a formula for aluminum hydroxide, with the stomach acid. Okay, now, sometimes this is what's going to throw kids off. They'll see this and they'll panic, but don't. Just think to yourself, aluminum, look at your periodic table, it has a charge of +3. Hydroxide is OH, it has a charge of -1. So if I write the formula, it's going to be AlOH taken 3 times. And then the stomach acid is HCl. And you can hopefully remember that hydrochloric acid, probably the most common acid you've used, is going to be what's in your stomach. Now when you look at this, this is no different than what you did in your first year of chemistry. It's just a simple double displacement reaction. So the aluminum is going to pair up with the chlorine. Remember, aluminum is a +3, chlorine is a -1, so you get AlCl3. And then H is going to pair up with OH, and hopefully you guys know that that makes water. Now you could balance this on your own. You should be able to balance this. Another example would be something like magnesium carbonate. Okay, so if you have magnesium carbonate reacting with the stomach acid, okay? So magnesium, if you were going to write the formula for magnesium, Mg is a +2 charge, and carbonate is CO3 with a -2 charge. So I have MgCO3 reacting with HCl, the stomach acid. Now again, a double displacement reaction is going to pair up magnesium and chlorine. And so Mg is a +2, chlorine is a -1. You're going to get MgCl2. And then I want you, hopefully, by now you remember that if you pair up hydrogen and carbonate, you would get carbonic acid. But carbonic acid is not stable, and it automatically breaks down, decomposes into H2O and CO2. So, balance that equation on your own too. And I'm going to have you guys, I'm sure you don't really need to check your work, but I'm now balancing these equations, and you can see if you did them right. Now, I want to talk about why we did this, because the second part of this question for IB will often be, which of these 2 antacids, aluminum hydroxide or magnesium carbonate, or whatever else they give you, okay, because these are not the only 2, but they would ask which one would be more effective. And I want you to look at your balanced reaction to answer that question. So which is more effective? All right, and if you look at, for every 1 mole of AlOH taken 3 times used, you are going to be able to neutralize 3 moles of HCl. But for magnesium carbonate, if you have 1 mole of magnesium carbonate, you're only able to neutralize 2 moles of HCl. So if IB asks a question similar to this on the exam, which one would be more effective? It would be the aluminum hydroxide, because it can neutralize more acid, more moles of acid per mole of aluminum hydroxide given. So that's the end of our acid videos. Hopefully that was fairly straightforward, but if you do have questions, we can ask the next time we meet in class.